Okay, we're in section 23, which is the section that introduces complex numbers. Um, the big concept over here is this new number you have, which is square root of -1, which we call the unit imaginary, or I. All right. So we went through some lecture material. I do want to point out in the lecture material, this is new to a majority of students. In other words, you have not seen this at Essex County College anyway. Math was the first time we introduce it. The subject gets even more difficult. What I mean by that, when you take trigonometry, we start talking about, you know, roots that involve complex numbers. The bottom line is over here, we're just introducing the basics of it. All right. And the basics of this is, the concept that I equals the square root of -1. Let me repeat this. We've already discussed this. However, you need to study this material. And there's little videos on the side that may or may not be helpful. You determine that. We talked about operation with complex numbers. And now what we're going to do is we're going to do the examples. So just give me a moment to switch over to another screen. And let me try to do that. And we'll go through one example at a time. So my goal over here is I'm looking at something and I want to see if I can actually do what they're asking me to do. So the first thing I want to claim to you is the complex number is new to you. So really, I'm always on the lookout now for this I business. And what's I? It's a square root of -1. I need to look out for it at all times. And I'm starting to see it right away. So I'm going to say that this over here really can be written as minus the root of -1 times the root of 75. Right now, I have to go backwards too in my notes and realize that the square root of 75, I could write down as 25, because that's a perfect square, by the way, times 3. So what would I get? The square root of -1 is I. The square root of 25 is 5. And the square root of 3 is, I have no idea. Now, by the way, I don't mind the way that's written, but most people would try to write it this way over here. They would probably write down 5 root 3 I. Now, officially speaking, they want you to write it as the A plus BI. So if you were to do that, this would be 0 plus 5 root 3 I. In WebAssign, they may ask you what the A is. In this case, the A is 0, and they might ask you what the B is. In this case, it's 5 root 3. I got to be honest with you, that's overly pedantic for me. I would much rather prefer to write down something that's simpler. So I'm going to say, this is really nice to write this down. Or if you want this one over here, I actually prefer this one, the 5I root 3, where the I is kind of buried between the whole number 5 and that radical on the end. All right. All right, let me go to the next question. Next question looks like an evaluation problem. And what's the problem with evaluation for a large number of students? Doing the arithmetic. All right, so I need to write it down. And I'm going to do one step at a time. I'm going to parenthesize the variables in the problem. So B, I get a root. B squared, I'll plug it in later. Minus 4A, I'll plug it in later. And C. Let's do this one step at a time. Now, I have to know what B is. If I don't know what B is, I couldn't plug it in. So let me point out what I mean by this. This is the B. What's the B? It's 6. I'm going to write that down for you. Again, I'm going to point over here. I'm going to put it over here too, right? 6. All right, now I got to do the A. What's the A? The A is -2. Write that down for you. And then I have to do the C, right? And what's a C? -29. Let me write that down for you. Okay. Even with the calculator, students tend to make mistakes. All I can say is try to be careful when you do the arithmetic. Well, 6 squared is 36, right? Next guy's a killer. And I know this because I grade a lot. I see a lot of students make mistakes with, when I say simple arithmetic. Before I do anything, I want to do the sign of it. And if I did 4 times -2 times -29, that's a positive number. So I know this is a subtraction symbol there. Right. I'm going to do this on the side for you. So I'm doing 4 times 2 times 29. I'm going to do it in stages. I'm going to do 4 times 2 first. That's 8 times 29. And again, I hope you don't need a calculator, but you know what? If you need a calculator, you need a calculator, all right? What's 8 times 20? 160. What's 8 times 9? 72. Right? Looks pretty tough though, doesn't it? So what do you get there? 160 and 72. That's gonna be 232, right? Write that down for you. All right, let's keep going. This is terrible, it really does. I'm gonna erase my baby arithmetic on the side. I don't really need it. And I'm gonna do some more baby arithmetic. I'm gonna take 36 from 232. Write this down for you. Yeah, I know it's negative. I'm just writing down the baby arithmetic over here. And what's it gonna give you? Well, if I looked at it, looks like 196. I realize some students struggle. There's no doubt about it. But before you struggle, what I want to point out is I definitely see the -1. And I'm wondering if the 196 is a perfect square. And what I mean by that is it a nice like integer number? And let me just go through this with you. I'm going to say it looks like 14 squared. I'll write this down for you. 14 squared. What's 14 squared? It's 14 times 14. We would like you to verify this. Now, by the way, the way I do arithmetic, the way you do arithmetic may be slightly different, but the outcomes can't be different. What's 10 times 14? 140. And what's 4 times 14? That's going to be, let's see, 40 and 16, which is 56. That's 196, right? So now I can do this over here. What's going to be? -6 plus I, that's square root of -1. And the root of 196 is 14. So what is this thing written down as? -6 plus 14i. Be aware that WebAssign may ask you what the A is. The A is -6, and they may ask you what the B is. The B is 14. All right, that's number 2. Let's go to number 3. Number 3 is a subtraction problem. One step at a time. We're not saying that you can't do this quickly. I'm just going to say I'm going to take one step at a time. I'm going to remove the grouping symbols. 5 minus 7i minus 6 minus a minus 19 is plus 19. I. Combine like terms. 5 minus 6 is -1. Minus 7i plus 19i would be plus 12i. WebAssign may ask you what the A is. That's -1. Whoops, that doesn't look right. And they may ask you what the B is. It's 12. All right. Let's go to the next one. Next one's a multiplication. What does this require? Distributive property of multiplication. I have to take the 1, distribute across these two terms, then I take the minus I and distribute across these two terms. Let's see what happens. 1 times 1 is 1. 1 times I is I. What's next? -1. I'm sorry, minus I times 1 is minus I. Then you get minus I squared. All right. Some things are really easy, like this disappears. And what are you left off with? I'll write down for you. 1 minus I squared. You should realize that I is the square root of -1 and I squared is -1. Let's write that down. 1 minus a -1. What is that going to be? 1 plus 1, which is 2. You may be surprised by this, but your calculators are quite capable of doing arithmetic, including with complex numbers. Let's go to number 5. Getting a little bit better at this. You can do it. 5 times 5 is 25. And then you can get 15i. Then you get minus 15i. And then you get minus 9i squared. I want to point out the prior problem and this problem have the same form. I'll tell you what that form is. It's a plus bi times a minus bi. And this is a really nice form. These are known as conjugates. right? They're conjugates, all right? Have we used conjugates before? Yeah, we have. Let's keep going through it. And I hope you realize that these disappear. That's what's really nice about conjugates, the middle guys disappear. And what are you left off with? 25 minus 9. And what's I squared? Well, we just did it. It's minus 1. So what do you get? 25 plus 9, which is 34. Again, check your key and make sure you're getting it. Let's do number 6. Relatively simple question. The I gets distributed across the two terms, 3 minus 2I. So you get 3I minus 2I squared. 3I minus 2, and I squared is minus 1. So we're left off with 3I plus 2. I do not mind the way that's written. However, not everyone is so flexible. They want them written as A plus BI. So it's going to be 2 plus 3I. Again, the A in this case is 2, the B is 3. All right, let's go to the next question, and that'll be number 7 on the following page. All right, this one's a little bit creepy, and I'll be honest with you, the reason it's creepy is that it's written as a division problem, but our goal is always to write it in the form A plus BI, with the understanding that A and B are going to be real numbers, and I is that unit imaginary. So although it depends, who's teaching the course, I'm going to multiply the bottom by its conjugate. And this might seem really strange to you, but the conjugate of I want to put what I is, it's 0 plus I. Its conjugate would be 0 minus I. So the conjugate here is minus I actually. Now what do you get on top? Pretty simple. You get minus 2I. And what do you get on bottom? You get minus I squared. Now I hope you realize the top is minus 2I. And the bottom is minus I squared. What's I squared? Minus 1. What do you get there? Minus 2I. Well, minus 1 is just 1. So the answer is minus 2I. So the claim is this. 2 divided by I is identical to minus 2I. All right. We want the form like this. The reason for it is I can identify the A and the B now. What's the A? The A is 0. What's the B? Minus 2. Again, answers are listed for you, and they're in the key right over here. All right, let's do the next one. This is number 8. Multiply it. We'll put the builder down. And what's the builder? The bottom's conjugate, which is 1 minus I. Remember, if you multiply the bottom by 1 minus I, you have to multiply the top by 1 minus I. Let's write this down. This should be 3 minus 3I. There's nothing wrong with that. If I do the bottom, and I'll go through it step by step, 1 times 1 is 1, minus I, I'm using the distributive property of multiplication, plus I, minus I squared. What's nice about the bottom? These disappear. Let's keep going. What do we get? 3 minus 3I. On the bottom, what do you get? 1 minus, well, what's I squared? It's minus 1. So what do you get there? Well, you still get 3 minus 3I. What's on the bottom? 1 plus 1, which is 2. By the way, I have no objection to the way that's written. Other people do, though. They split it into 2 terms. 3 halves minus 3 halves of an I. Now, why would they do that? They can now identify the A as 3 halves and the B to be minus 3 halves. Let's check the key, see if we got the right answer. And we got the right answer. All right, let's go to number 9. Relatively straightforward. And go to the top by its conjugate. And we'll say conjugate at the bottom. The conjugate at the bottom is 3 plus I. Let's do the multiplication on top first because it's easy. What do you get? 15 plus 5I. On the bottom, I'll go through all the details. However, if you can do it quickly and write the number down, that's fine by me. You don't need to go through all the work. 3 times 3 is 9. Plus 3I. Minus 3I. Minus I squared. All right, what's nice about this? Well, conjugates, the reason we use them is these guys in the middle disappear. And what do you get? something pretty simple. You get 15 plus 5i, and at the bottom you get 9 minus a minus 1. 15 plus 5i, 9 minus a minus 1 is 9 plus 1, which is 10. I have no objection to the answer, by the way. However, I want to write it the way most books would write it. 15 over 10 plus 5 over 10 I, and they would reduce it by 5. 5 goes into 15 3 times, goes into 10 2 times. 5 goes into 5 once. Whoops, made a mistake there. 5 goes into 5 once, goes into 10 twice. And that's what most books would put down for the answer. Let's see if you got it right. 3 halves, plus a half an I. What's the A? The A is 3 halves. What's the B? It's 1 half. All right, let me go back to that repeated mantra of mine. You got to practice. Like you can look and say, oh, I'm just exhausted. I can't do anymore. You really haven't done much. You listen to somebody, right? You listen to me present lecture. You listen to me go through a couple examples. Hopefully you're taking notes. Hopefully you're thinking about what's being presented to you. The bottom line is though, you can be tossed out into your own to do the work on your own. What do I mean by that? You got to do the homework. Now, as you do the homework, you're going to start to realize the homework looks just like we've done in class. Yep, you're given an opportunity now to try on your own. Make sure you get those problems. At the end of the week, I'll be publishing me at the whiteboard doing those problems. However, if you need additional help, please come by during office hours where I can help you through the problem set. Okay, thank you.